Good morning, and we've returned here at the Hyatt Regency on Capitol Hill, 400 New Jersey Avenue in Washington, D.C. This morning I'm on the topic, the amazing 5x12 matrix, and we've been using the output of the amazing 5x12 matrix. Some of the outputs are some 3x3 matrices, 4x4, 2x2. And we have sought to alter them now to enhance some circuit analysis by the mesh method. And so here, this morning as we continue, I promised to do some 3x3s. I previously did some 2x2s. I think my first one I did was a 3x3, but we have a return to a 3x3. And here we have now, let me just write my name here, it's a convention. And the circuit in particular here we're going to solve by the mesh method would be, here we have it, it's the voltage source. Ohms here, minus J2 ohms here, 6. Notice we've been in the complex domain now with the capacitance and inductance. We're going to be finding some complex power with the units in VARs. This is resistance, and this is inductance. Capacitance, minus J 6 ohm here, and like that. Current in the anti-clockwise direction here, I2, we assume it to be so. If it comes out, if I2 comes out negative, then it's in the reverse direction. But we have to assume it to be so. V2, and this is now 6 angle 30 degrees, and this is 3 ohms. That's also going in the anti-clockwise direction. And this is I. This is now 2 ohms, J4 ohms, and we have Vx here, which we want to determine. VL 10 angle 0. Yes, I think we have all the elements and their magnitudes. And so we're going to find I1. We're going to determine I1 by the determinant of the 3x3 matrix. And if you write down my inspection now, we have now that 10 minus J2, 0, 4 minus J2. This is the first column. This is like the R11, R21, and R31. And this is 0, 6 minus J6 minus 3. And this is like the R12, R22, R12, 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3 4 minus J2 minus J 9 plus J2. I1, I2, I3. Ten plus J0, 5.2 plus J3, and 0. And notice there I've The only change I've made is that in previous sessions we have used delta as our denominator value, as a determinant of the 3 by 3. I've used del it instead now, and del is just a upside down delta. Del goes to del. Del goes, this is really del, and this one is delta, and upside down. And so, what we have here now is that in determining I1, we'll have now 10 plus J0, 5.2 plus J3, 0, 0, 6 minus J6 minus 3, 4 minus J2 minus 3, and plus J2. And this is over now there. And if we do the determinants we get now, that's equal to 648.2 at an angle of minus 40.95. And that will be over 627.7 at an angle of minus 35.67. So that's after we find the determinants here. And notice here that if we impose or superimpose delta upon del, we get something looking like the Star of David here. And suppose if we should use, instead of delta or del, we use the Star of David. So what we'll have here now is that this one will become now anyhow, that's and that, and we do the calculation here, we get 1.03 upon minus 5.27 amperes. So that's the value for I1. Now the complex power associated with the I1, we put now the complex power associated with I1 will be S1. And that's equal to V1 I1 star complex power. And that's equal to 10 angle 0 times what we have just calculated, 1.03 10.0 and 1.03, 5.27. Where we get this? 5.27. And that will be equal now to 10.3 at the angle of 5.27 VA. That's bars, that's complex power. And let me just raise up my little camera here so that we could see that properly. Yeah, so what we have done, we have found I1 and small changes here. I've changed from delta to del for reasons to come. This is del is associated with divergence theory, and find the Jacobian and all of that. Whereas delta is used to in small increments in calculus, delta or the Kronecker delta. Anyhow, here we are, and so we have found I1 and we have found a corresponding S1, the complex power associated with I1, by finding S1 is equal to V1 I1 star, and we have written 1.03 5.27 bars. And so we'll go over now to find I2 and the corresponding S2 complex power, I3 corresponding S3 complex power, and we're also going to find Vx. So let's take a break.